Hi there, my name is Philip Zook. I'm the Vice President of Technical Marketing at Transphorm, and here to speak to you this afternoon on how our GaN technology is continuing to bring awareness to GaN adoption and disruption into the market. This afternoon I'm going to give you a short update on Transphorm in 2020, our collaboration with Microchip, talk to you a little bit about our latest Gen 4 SuperGaN platform, do a comparison against silicon carbide, and then follow that up with a summary. We continue to drive our high volume production with an installed base of well over 220 megawatts in multiple markets with different customers as well as different power levels. Our key to our success is basically 4 areas, and that's the best-in-class reliability, the ease of designability and drivability of our technology, as well as high volume reproducibility. As I stated earlier, we just recently released our next generation or Gen 4 SuperGaN platform, which offers increased performance, figure of merit, and also a reduced cost structure. We continue to drive our best-in-class quality and reliability with a fit rate of 1. Well over 600,000 devices in the market today with over 6 billion hours of field reliability data, which equates to 3.3 dppm, which is defects parts per million. And now, as of the end of February, beginning of March, we are the first pure-play GaN public reporting company. Our collaboration with Microchip allows Transphorm to fill a void or an educational need for digital firmware development within the power electronics community. This is where Microchip comes in. They provide the firmware expertise and worldwide support, where Transphorm provides the hardware and its worldwide support. I've already received positive feedback on making designers' lives easier with this solution and support structure. Let's talk a little bit about our Gen 4 SuperGaN platform, which was recently released. Continued to have proven reliability and robustness with plus or minus 20 volts maximum on the gate and a 4 volt threshold, just like driving a high voltage silicon superjunction device for increased noise immunity. We continue to drive the performance of our technology with a flatter and higher efficiency curve and improved figure of merit. I talked about the ease of designability and drivability. Well, we continue to drive the ease of designability because you no longer need a switch node snubber. So this reduces the number of passives that are required around the device. All you need is a gate resistor, a ferrite bead, and away you go. Now that we've also reduced the inductance within the package, it is quieter switching and enhanced EMI. And with that, we've also simplified the assembly process. So with simplifying the assembly process, we've actually reduced the cost of the devices as well. It has been mentioned that silicon carbide may outperform gallium nitride when compared to a similar on-resistance value, not at 25 degrees C, but at 100 or 150 degrees Celsius. To remove this myth, we use a totem pole PFC running at 65 kHz and compared our latest 35 milliohm Gen 4 SuperGaN FET against a 60 milliohm silicon carbide device. Now both of these on-resistance ratings are at 25 degrees Celsius, which equates to a 25 milliohm difference. But at 150 degrees Celsius, the ratings are much closer, 72 and 77 milliohms respectively. Now in comparing these two devices, one can see that with silicon carbide having a higher 25 degrees C rating on resistance, which gives it an advantage of lower charges and capacitances compared to a 25 degrees C comparable silicon carbide device to our GaN device, that its performance is at best equal in efficiency to approximately 1200 watts. Any power level above 1200 watts, GaN is a superior solution due to its greater than 2 times higher electron mobility, resulting in lower crossover losses and ultimately resulting in a greater than 20% decrease in power loss at applications where the maximum output power of this application is 4 kilowatt. So our technology at Transphorm continues to get designed into a broad range of applications and power levels. We are not limited to a certain power level, a certain market or application. We can continue to work on collaborating with outside semiconductor companies that offer complementary product portfolios, and again continue to evolve our technology by maintaining best-in-class reliability, the ease of designability, drivability, and high volume reproducibility. I want to thank you for taking the time to listen to my presentation this afternoon, and if you have any questions, please visit us at www.transphormusa.com. Thank you very much and have a great day.